right, let's get going, shall we? Good evening, all. My name is Nolan. I'm Executive Director of the Atlanta AI and Robotics Initiative. Just a couple of months ago, I was a Senior Solution Engineer with Microsoft. I'd been there 5 years with a variety of roles. Then Dave and I built a data center in the garage and ran into the problem that we're going to address this evening, which is students aren't touching enough hardware and don't know the entire ecosystem of AI to be successful in the modern enterprise. Did I mix that up, Jeremy, in any way? Okay. So when we have some couple people inside the wait. Oh, okay. Hold on. Nope, everybody's in. Yep. Yep, you are welcome. So let's get on with the agenda, shall we? At least with my portion. Dave is going to be with the hands-on. I'm going to give a little theory. So don't worry. And thank you for bringing your laptops and for coming, by the way. So this is the team. I'm Executive Director, as we just mentioned. There's Dave there, Nick and Dorian. I'll say a few things about this. I have a founder, 75% are Morehouse graduates. Nick is one of the OpenShift and OpenStack experts in the world, right? And brings another sort of flavor to the team. And I also want to say I'm the only Morehouse honors graduate on the team. The rest are thank you, Lordy. And I really am going to emphasize that every single time. Who are we? Why are we here? A few of you went to QCS, what, a couple of weeks ago? How was that? Why? Who are you, by the way?
What's up, everybody? My name is Jeremy Samuel. I'm a senior at Morehouse College of Software Engineering there in California. To the president of ACC, the largest computer science and tech organization in the ABC. So I'm super happy to collaborate with Nolan. We met at Afrotech actually. Hit it off there, and he's explaining to me his vision. Like this perfectly aligns with me. So a couple weeks ago, we actually were able to tour TS, which is a data center. Yeah, we were able to tour QTS, which is the data center. Really talking to a lot of the employees and things that are working there. Just hearing, what is actually happening inside a data center and asking the real questions, what's actually happening behind the scenes. So we're actually taking another group, because so many people are interested, in 2 weeks. So we're going to go back and really convene folks that have been. So
absolutely.
Thank you,
sir. Yeah, I can't go because I'm getting married. I'll be off to Mexico. But I know you guys won't be that unruly, and we'll have a good time and ask questions. But the thing I want to emphasize is we're not just teaching theoretical concepts, right? We show real systems, and they all fit into place, right? First started in the garage with like the research. QTS gives you that vision amplified, right? Megawatts and gigawatts, and give you the students access to enterprise grade systems, right? Which you're currently not getting now from everything that Gabriel and Jeremy tell me on a regular basis. So that's what sets us apart. Let's move on. The master, David.
Master Bruce C. We'll read this?
Sure.
All right. So absorb what is useful, discard what is not, and add what is uniquely your own. This is from my master, Bruce Lee. And if any of you are unfamiliar with Bruce Lee's world-renowned fighter, but what made him smart was that he recognized that any individual style just separates. Every style has something to offer. Take from that. You have to make your own style.
Yep. Thank you, sir. He rejected rigidity, right, in his martial arts system. We reject vendor lock-in, right? Absorb what is useful, learn from any tool. Discard what is not, don't get trapped by frameworks. and add what is uniquely your own. Develop your own intuition. This is viewed as a fighting philosophy, but it's really philosophy towards life. And by the way, those of you who are here in the spring, I highly recommend that you join the Morehouse Boxing Club for a few reasons. And I see you smiling, Jeremy. You've been an entrepreneur. Entrepreneurs get punched in the face. And you need to learn to do that. Say, hey, I've been hit before, and strike back, almost like playing chess. You're going into the most virulent, racist enterprise probably in 100 years. And I don't care if it's academia, entrepreneurship, or the enterprise. How do you survive that? Oh, you get hit. Oh, hit that before. Mike Tyson, strike back. Let's move on. So this is controversial but important. Vendor certifications aren't bad, right? Like your hyperscalers, AWS, Azure, what have you, but they want you locked in their ecosystem, right? And once you get locked in the ecosystem, you become what, Dave? A paper tiger, right? And if, no offense, Salesforce, but if that goes away tomorrow, what are you going to do? It's a single point of failure, right? We reject any labels like that, right? Take what is useful, discard the rest. Don't get locked in. Partnerships, I think we already thanked the AUC Data Science Consortium, QTS, Red Hat for the technology, and that's actually a typo, I apologize. It's ATDC, which is the lab we're going to be using at Georgia Tech. So you guys can actually build a data center and learn. More to come. I think you should take this one.
Me?
Yeah.
All right, so this slide is standing on someone else's shoulders. What does that mean? Generally speaking, does anyone have an idea what standing on someone else's shoulders mean? Go ahead.
I see that as essentially someone else's resource. Essentially, like your parents, you know, you have standing on their shoulders.
Right. That's a great example. Great example. Go ahead. What's your thoughts?
Using the efforts of other just to get that extra step.
That's right. So, in general, there's nothing new under the sun, right? There's nothing new under the sun. You don't have to, if you want to drive, you don't have to reinvent a car. You have to invent the engine. You don't have to make gasoline. You just have to go to the person that's selling it, get it, and then drive and go to where you want to do. So the car enables you for things. You drive to work. You drive to create. In IT, standing on someone else's shoulders is the open source philosophy. How many people are familiar with open source as a term or a community or anything like that? Familiar? So what does that mean? That means that you can take something that has already been invented and use it to your advantage. How many people have iPhones? How many people have Android? Oh, booze!
Open source. Open source.
In my view, because they run off of Linux. So Linux is really just a kernel which handles all commands, and all the other programs really just help Linux become the operating system. But Linux itself is just a way to manage a device. All Android devices have a Linux kernel. So Linux is available. Almost everyone has Linux in their pocket. Your televisions, this projector probably runs Linux. The Wi-Fi probably runs Linux. Your the cameras probably runs Linux. All of it runs Linux, the Linux kernel specifically. All these companies are doing are standing on someone else's shoulders. The people who have Raspberry Pi devices or just watches, those are all standing on someone else's shoulders. And for iPhones, to wrap it all up, that's using a Unix-based kernel, which is similar to Linux, but this Apple doing it on a special set. But they're standing on someone else's shoulders. All the hard work has been done for you. It's just up to you to figure out how to do that.
Linux is used in 90% of servers, and open source has been refined by millions of engineers, right? Um, Tools come and go, but the fundamentals don't change, right? Whenever we're talking, I say blocking and tackling. Learn those, and the tools don't matter. And that's what we're going to teach you today. It starts today with the Linux fundamentals, right? So let me get through this so you can get there. Okay. Altering what I literally just said, right? Teach the foundation, Linux and networking. Only a few of you said you know about Linux and a few command changing directories, things like that. Fair enough. Platform and orchestration, containers, AI and ML, right? Training versus inference, kind of like what we're going through in the Math ML class. Edge AI, also what we're doing in the Math ML class, right? Running the compute near the data, right? Running the data near the compute, all right? Take away a step of latency. And then the application layer in this case is robotics, the body that proves that everything works. Most start from up here and go down. We start up, all right? You can't deploy AI if you don't know networking. I found that out of Microsoft the hard way, right? Quick break. What do you guys want to learn and get into? Isn't there a hackathon coming up? What are you guys teaming up and working on? Shout it out real quick.
Like what we would like to learn.
Yeah.
I mean, it's gonna be.
Who are you talking about?
Oh yeah, Mally Desi, junior computer science major from Morehouse College. We have a hackathon coming up on Friday. In terms of learning, I mean, straightforward. I don't know. I don't necessarily know.
What are you working on for the hackathon?
Huh?
What are you working on for the hackathon?
We don't even got the prompt yet, but we know it's gonna be like it's probably gonna be an app. You gotta integrate AI to solve the problem.
Aaron Beckway, senior computer science major mathematics from Dallas, Texas, in Morehouse. And we have a hackathon. We have one this week, and then we have another one next month that I'm working on. Trying to see how we can that
The workshop as well. All good.
All right. So
Moving along. Let's see. Going to do is make that a bit smaller. So, this is the career opportunity slide, right? You see so much data scientists everywhere, but who deploys the models, right? That's the gap, and companies pay high salaries for like ML ops engineers, right? Basically, and we'll teach you to fill this gap and others to make you employable, or the engineering mindset to start your own business. Who knows? Now, let's break something and fix it. Who's ready to do that? All right. So, let's say hypothetically, you are a consultant and your client is a barber, right? It's Friday late and you're on call, right? The owner is blowing you up because the customers can't book, and it's your job to fix it, right? This is what the customer sees, right? Which tells us nothing, right? Just that something is broken, right? There's a server problem, but it doesn't really get to the root of what the issue is, right? But we'll need to dig a little bit deeper. Jeremy, this is all you, Docker, right? The container is up, right? But don't assume. Just because the customers can't book doesn't mean the container is broken, right? Or it's down. Always verify the basics. Docker PS, right? Is your first command in case the container is up, so the problem must be someplace else.
Before you go to the next slide, can you go back to that?
Yes,
So
sir.
does everyone know what this means? Is the service running? You know what that means? Well, Well,
Oh, Dave.
thank you.
Mm-hmm.
We're just gonna go over this right here. So there's a problem, as Nolan has stated. You have a barbershop, and you need to be able to get a fresh cut, right? Got to go out on a date. Got to be fresh. For me, I got to have that black stuff sprayed on my bald spot to cover it up. Y'all know how it goes. So, but I can't do it. It's down, and it's your job. How are you going to fix it? So one of the things that you may want to do is see if the web service is running. So that's the service, right? The web service. You can just type in www.whatever.com. There's a web service runs on ports. Anyone? Port 80.
Yeah, right.
So these are names that actually translate to numbers. Web servers port 80. A secure, when you look on the website, say, oh, this website is secure, it's port 440. So as a professional, you have to know that these are standards. And you ran a command to see if the web service is up, docker.ps, it's a lot of different things. Yes, question.
Question, so you have like multiple clients, all those are right.
Basically, that I'm oversimplifying it, but yes. So any website that you're going to is going to be able to port 80 or 443. That's a fantastic question, because when we want to talk about web security, we want to talk about things that is not secure, right? Don't get on an unsecure public Wi-Fi, because all your data is sent in clear text, and they'll just be able to snatch your Instagram password and start profile, right? So that's why you would want to have port 443. Port 443 is a web service, but a secure web service. So these are things that you will come to learn. This doesn't really matter how it works underneath, but it's what the service you're providing. So 443 is secure. And it's a fantastic question, because there's a difference between unsecure and insecure web traffic. So right here, this shows that it's up and running. Services now. Nolan, if you go to the next slide.
Yes, sir.
So what do the logs say? So if it looks like it's up, and this is something that you would do if you have a job, right? Besides our theory of comp sci and machine learning, when it comes down to it, they're going to want you to keep the money coming in. That's the only point. That's the only reason why you're going to be working for the business, to make money. You got to keep it coming in. And if these people cannot connect to your service, they cannot book haircuts, fresh cuts. They cannot collect money. Your haircuts looking messed up. You're not going to go out and have any play, and it's a bad night. So right here, your job is to look. You see that it cannot connect to the database. That's a problem. You know that it's supposed to connect to the database. What's the next slide?
Yep.
Next slide, please. So there's things that you can do to troubleshoot, and these come from knowing where the problem is. Troubleshooting. If your car won't start, what's the first thing you look for? Gas. That's what this is. You gotta check to see if you can even get anywhere. You see if there's any gas, right? If the TV won't cut on, what's the first thing you think of? Boom. Is it plugged in? Troubleshoot. That's what this is. So there's certain things that you have to become familiar with in the world of troubleshooting. So this ping, a ping is a command. Like if I were to throw you the ball, you'll catch it and you throw it back. It's ping. So if you throw a ping to a server and they don't get it back, service down. So it looks like the DB is hanging. So let's go to the next slide. And there's some other errors. We can get into that, but there's all this other stuff. So this right here, we see that website's running, but the database is not working, or the database name is different. We're trying to connect to something different. So this example is kind of crazy, because the database changed. It should never happen. But it's legit.
It's just a config issue, basically.
Yeah, that's what it is. So that's for you to know. Now, I'm going to tell you something. The most nerve-wracking thing in your future career will be to hit that enter key where you know the answer. It's like almost submitting an answer to a test. We know, I hope this right. Oh, Lord, don't fail me now. And you just got to hit that enter key. But it's by you doing this over and over again and being confident that if you get the wrong answer, you can correct it. that gives you confidence in that enter key. So once you get this enter key, go ahead and hit next, go to state 5. You see that it's pointing to the wrong thing. We're feeling confident, we can fix it. You see that the configuration is wrong. We're going to correct it to instead of DB host, it'll be Postgres. Let's go ahead and go to the next slide. And so you're really confident, and then you fix it. This is the money maker. This is when you are confident that you've done your troubleshooting. You see that all you have to do is just change a few commands and hit the button, hit enter. The booking system loads. Your boss says, thank you. You get the rest of the day off because you're a firefighter. As an IT guy, you're a firefighter. They're not going to need you when everything is working. They're going to yell at you when things are broke. That's the stress of the situation. No one cares about what you're doing until it breaks, and then they're wondering what the hell are you doing. And so knowing the underlying that application of theory, everything that you're learning in school right now is theory. Right? This is how it should work. This is how it really works, and how you go use the tools to fix it.
I have a question. How might an issue like this where a big file got small?
Right. Fantastic question. So this question was, how in the world could something like this break? Right? And the answer is one of your coworkers messed up. Or AI, you told AI to go and do some stuff, and it was totally the wrong thing. AI generated BS and iPod because it'll all look like if you don't know. The problem, the danger of using AI to do things is that if you don't know what the right answer should look like, it's just going to look correct. And then someone else who knows what's going on will be like, that's awesome. You know, I mean, because they'll just take one look at it and be like, you're like 80% there, but the conclusion that you're drawing is completely wrong. And it will manifest itself in things like this. But you tell AI, point the web server to the database. It says, okay, we'll point to this one, but it's completely wrong. And that's where you, as a subject matter expert, like I know how this is supposed to work because I built it, will come in and save the day. And that's how you will always have a job. Because you know how to use the tools. Like, oh, you gave the wrong prompts to the AI. It's like, you never say that to the AI. It's always wrong. Because you know, that's the value that you bring and the value that experience brings. You can't fake. You can't fake it. One thing I want to tell you with all this is a little aside. If you do not know the answer to something, and this will help you in your career, in your life, and your relationships, say, I don't know. People can detect BS 100% of the time.
Especially in this industry.
If you just there's a right answer. There's a right answer. You're like, well, see, he just knows like, oh, you're fine. Get out of here. I don't want to hear it. This is real. But if you say, I don't know, no one knows. No one knows. They're like, we're trying to figure it out. If you don't know, cool, we'll all figure it out together. So I can rattle forever.
Almost done. It's almost your part. If anybody tells you they know AI completely and everything that's going on with it, they're lying. So this is the slide. Take this information down right now. Talking to you, everybody in the crowd. Take this information down. It's a methodology. And there's a reason why I went over the theory before you just started hacking away on the keyboard, right? Understand what you do before you do it. This like solves like 80% of production issues at Dave's point. All right. And they're universal, and they work for any system, any technology. This is the gift we're giving you today, besides a hopefully good Mexican food. Now, if Dorian were here, he'd tell you that what we just told you will get you about $150 to $300 an hour, and you just learned it. We are unabashed capitalists. Him a little bit more zest, more feisty than me. I'm more about corrupting the system, but same conclusion.
I like money.
So, before we go into the red hat portion of things, be water, my friends. Remember, freshman, sophomore, physics, quantum computing, meet me after the workshop. Go get a bag or something. Come on. Thank you.
All right. All right, thank you, Nolan. And I'm gonna just elaborate a little bit more about that, Bruce Lee, about Be Water. Can you bring up the emails at the much bring up some stuff?
I put it all on my drive.
Okay, excellent. So Bruce Lee had said, to elaborate a little bit more about Be Water. Water changes the shape based upon whatever container it's in, right? You put it in milk jug, it becomes a milk jug. You put it in ice cubes, it's ice cube. Water can flow and it also can crash, right? You don't want to be underneath the crashing wave. You maybe want to be in still water. Be water. Learn how to adapt to your environment. How many of you know how to swim? Oh, hey, I got a group of black people.
These are bougie black people.
No, so but how any of you know how to swim good? Okay, so what does that mean? It took me until I was almost 40 years old to know how to swim well, and also to stretch. Y'all probably don't know how to stretch right. So you get old, that's how you do it. But swimming, if you know how to swim well, you can only swim so fast. After that, you're just splashing, you're wasting your energy. And you don't want to swim against the current, you want to swim with the current. That is life. Sometimes you may find yourself going against the current. You need to turn around and swim with it. It may take you in a different direction, it may take you to the direction you're trying to get out alone. But the fact of the matter is that you have to know if you are wasting your time, burning up too much energy, going the wrong direction. And that is something that you will regret if you spend too much time going in the wrong direction. So how do you know if you've been going in the right direction? Number one, you're happy and you have money. Those are two things, right? If you feel successful, you feel like I did something today, and you feel, hey, someone just gave me some money for something that I was there for free. You were on the right track. Because when I was in Morehouse, I built computers for beer money. Right, I just would build computers. My buddies would come over. We would play Quake. We would play Duke Nukem, and they would give some money, and then we'll go get a 40 ounce. Right, this is beer money. And then eventually, I was out networking, just meeting people, just talking about technology. All of us are interested in technology. What you should be doing is going out meeting people who are not like you and getting outside your social circles. Because you'll find, oh, hey, well, you're not so different than me after all. And you'll talk nerd stuff and do be like, hey, man, I got a job. Come on over here. I give you $300,000 a year to talk nerd stuff with me. It'll just blow your mind. But that's how the world works. But the world, you're not going to get a job by submitting your skills to an AI that is set up to filter out other people that it doesn't want. How you get a job is you have to meet with people, and then you have to talk. You demonstrate that you know what you're talking about and you're eager to learn, and you'll get hired. So what I want to do right here is talk about some of the skills that you would need in the real world to get hired. And this right here is, okay, cool. Thank you.
Good.
So what I'm going to do right over yonder, this is, I've started work for Red Hat, right? This is Red Hat intellectual property. So I'm not going to show everything in it, but a lot of it is applicable to all Linux systems because all Linux is the same, basically. It's using a Linux kernel and just some tools that are set around it. And there's basically like 2 to 3 different kinds of Linuxes out there. There's usually a Red Hat based one, which is like RPM based. But then there's Debian and Ubuntu. You'll run that in Raspberry Pis and whatnot. And then there's other flavors out there, but basically there's Red Hat, not Red Hat. It doesn't matter underneath the system. Really, it's just how you install. That's the real difference. But because I'm familiar with Red Hat, I'm going to teach you some of the open source skills using this as a platform. And I also have some virtual machines that are fired up that you can access if you have your laptop here. It's going to be a little bit difficult with this one because this is our first time having this type of setup, and they don't. So this place doesn't support Linux connecting. So this is one of the things that you're going to run into. Everybody uses Windows and Mac. All the users, like the consumers, you. But all the creators, Linux. So this place is for like consumers and they don't have a lot of other stuff, so I can really share how to access all the other stuff. But I'll try. You have a question?
I have a question. Why is that the case?
Yeah, why is it the case that you say the creators use Linux and everybody else just uses Mac OS and Windows?
Fantastic question. It's because Linux can be difficult to use. And Windows, you kind of turn it on and it tells you what to do. That's one thing. That's one reason why I do not like it. Tell with my computer. But for you, you're like, oh, I don't know. So you hit a button. Macs have made an industry out of making the computer experience one button. Right? Your iPads, your iPhones. Like the iPhones used to have one button on them. Now we have no buttons. That was really an innovation. Before iPhones came out, phones had all types of buttons, like keyboards and everything. So Microsoft and Apple have succeeded by making computers easy to use. Linux is complicated, but it's easy to use if you know what you're doing. It's like a mechanic. If you know what sockets that you're going to use, it's not complicated, but if you never worked on a car before, the sheer number of options will scare you. So with this, there's really one slide that I want to get to here, and it will explain. So I don't know how to use this like that. Let me just go ahead and scroll down. Like I said, this is a little bit different because I'm using a different laptop. So it's 1 second as I go to the part that I wanted to start at. So this is chapter 1, getting started with Linux. Just imagine that doesn't say Red Hat Enterprise Linux. But briefly, why should you learn Linux? Linux is a critical technology for IT professionals to understand. Linux is in widespread use worldwide. Internet users interact with Linux applications and web server systems daily by browsing the World Wide Web and using e-commerce sites to buy and sell products. Linux is being used for much more than the internet. It manages point-of-sale systems in the world's stock markets and powers smart TVs and in-flight entertainment systems, runs most of the top 500 supercomputers in the world. Linux provides the core technologies that power the cloud revolution and the tools to build the latest generations of container-based microservices applications, software-based storage technologies, and big data solutions. Finally, in the modern data center, Linux and Microsoft Windows are the predominant operating systems. Linux use continues to expand in the enterprise cloud and device spaces. Due to its widespread adoption, you have many reasons to learn Linux. So these reasons that they give, a Windows user needs to interoperate with Linux systems and applications. That's absolutely true. If you are a Windows-only user in corporate America, you're just going to be limited in scope. They're going to say, hey, change the printer paper. That's what we used to tell our Windows guys. Hey, man, there's not a printer paper. In application development, Linux commonly hosts the applications and the runtime. So a web server, a Kubernetes platform that will run containers, it's going to be Linux-based. In cloud computing, both private and public cloud instances use Linux. Mobile applications and Internet of Things use Linux. When looking for new IT career opportunities, Linux skills are in high demand. So I just want to leave with that. Now, you may have a question of, so what makes Linux so great? It's open source technology. Going back to that slide where we're talking about standing on the shoulders of other people, that's how you do it. Think about it. When you're in school, you're teaching him to figure everything out. He has a book that he either learned from someone else or he wrote himself from an education he had. That is how the world works. That is how everything works. That's how technology works. The programming languages, the example programming sections, the math theorems that solve a lot of the problems, right? All these were made by smart people a long time ago, using it to build whatever, engineer like big things. So, the good news about open source technology is that you can use it for corporate work. So you can use it to make money off it for commercial use. Some of them. We're not going to get into that, but generally speaking, any app that you have, if you go to get this app and it'll say open source license, because they didn't make that. They didn't build that road, they didn't build that building, they used that road, you know, to get them, bring you there. It's already there. All these tools are already there. Everything that you want, that you need to become successful is already there. Just as like you can pick up your phone and become a streamer and make millions of dollars, you can pick up your laptop, open up some Linux, and make a whole new company, an entire industry. You can make an entire industry. So, any questions? Any questions about that? Anybody curious about Linux and how can I get it? So, I wish that my other laptop was up so I can show you exactly how I was just able to spawn about 10 instances. I have about 10 virtual machines that everyone could connect to. Having everybody share that information would probably be probably out of scope. But what I can do is you can see me connect to a Linux system that I just started up, and then I can add users in, and then you can connect to that. So what we'll do is I'll configure one system to allow everybody to get in there. And this will be a true test of my skills because I don't know this computer. I don't know if he hasn't, you know. So, but I do know the systems that I just started. So let me see if I can figure this out. Okay, so I'm going to just, if we have like a 5 or 10 minute break, everyone can go get some food. I know you've been sitting here for like an hour and a half. If you want to take a break, then come back. If you haven't had any food, it's over there. If you want to get a drink, and I'm just going to go ahead and get this started. It's going to take like 5-10 minutes, okay? All right, thanks everyone. So funny, I really don't know how to use this Mac. So if I remember correctly, oh, here we go, down here. Yeah, I'm looking for a terminal. So how do you type? I think it's right here. How do you type up? How do you search for terminal?
Yeah, you use apps. There's a shortcut for it, but I should know it, but I don't.
Oh, apps right over here.
Apps is right here, or applications.
Oh, okay. Thank you. See, I haven't used a Mac in about 10 years. So, all right. So let me break this out. Get my IP address.
You mind if I watch closely? I'm curious.
Oh yeah, yeah. So I'm going to let me just make this window bigger so that we can. Where's that? Yeah, come on. Oh, I got it. Yeah, it's similar enough that I can do that. There we go. All right, so I'm going to secure shell to this password. I wonder. So
gonna SSH to your computer.
Yeah, so if you want to see right here, if anyone wants to look and see what I'm doing, they can come up here because I can't share it all of it. So I fired up on AWS 10 servers right here.
Okay.
If you see right here, it's an AC lab, yada yada yada, yakety smackety. They've only been running for maybe like an hour. I just started them about an hour ago. This one has an IP address. What we're going to do, so I have a key set up. What I'm going to do is I'm going to secure shell here on this machine to the public IP, and then I'm going to create new users for us. So let me see if I think it should be Fedora at this. I'm on my other computer. Yeah. So I made a. Let me see if I'm gonna use this key. So my key should be in the downloads directory, and I think it was AU2 lab. So right here, I'm secure shelling, remotely accessing using this key I created earlier today to this system that I just fired up, and I'm curious it should work. I don't know what the user is. Let me see if I think it's cloud. Automatically creates a user. Let me see something. Let me see if sometimes I have settings in here that mess things up. So I have a per host configuration that I use to like access all my other systems. I'm just going to comment this out so it's not interfering.
You don't use Vim, you use like VI.
I use VI. Yeah, I use Vim. Vim and VI are basically the same. Let's see what users for Vim. No, pretty sure it was cloud. Oh, cloud user.
It wouldn't say on the AWS.
AMI? Yeah, you're right. It would say. Let me see. So I just fired these bad boys up. Let me see if my AMI right here. So AMI is machine image. That's just what you are firing up. Let me see if Fedora 42. You know what? Sometimes it's easy just to Google it. Let me see for a default user. And I'm pretty sure it is default username was core. No, that's not it. Live user. Let me try something. Because this is my first time even connecting to this.
No, it very much be like this.
Yep. I'm glad that you understand.
Very much understand.
Yeah. It's supposed to be either Fedora, a cloud user, or EC2 user. Let me see EC2 user. It could be that my my keys let me see 600. My key may be insecure. That's another thing. AUC2 lab. I'm going to put it in the secure spot, and I'm going to change the permissions. So AUC2 lab. So what I did right here is I moved it to my secure shell folder, and then I changed permissions so that only I will be able to access it. And now, let's see if I. Let me just see what the let me go and read the documentation and see what this is instead of poking around such a default one.
It's a container. So you know how containers go and share.
Launch.
Would it not be shown in the dashboard? Over there before?
And then like
No, it doesn't really show it. So at least if it does, I don't know. I gotta take off my glasses because it's too close to be able to read it. Right. Let me see. Rootman. I'm pretty sure that I have to look at the AMI to get it, but it's 42. Let me see. Cloud user.
okay, yeah.
So it's broken.
I'm pretty sure it's. Oh, default user is Fedora. Okay. So I wasn't too wrong. But I have too many authentication fails. Let's see if I can tell it to use a key.
So what is Fedora exactly?
It's just a different form of Linux. That's all it is. Different form of Linux. So it should be the key. You know what though? Troubleshooting. We're going to turn up verbosity to see if what it is. Okay, so authentication has continued. Let's try a different key.
What's up, man? How you doing?
Mark down.
No. Okay.
Freshman computer science major.
Oh, okay. All good. All good.
I heard you were talking about some computing stuff.
Yeah.
Okay, so I just turn on debugging.
I'll be honest in that I felt like I was
Let me see.
we weren't starting far back enough, right? I deployed AI, didn't understand the physical need for it. I won't have that be the same mistake for you guys, right? We need to start back with energy, right? Right, energy, chips, infrastructure, models, application. application in this case would be
You
robots,
said the
right?
live iOS is used live
And
user.
besides like the Ohm's law and stuff like that,
Yeah,
like
but I tried live using. Well, we could try it.
charting
but then
energy and
I don't
putting
know
it
why
on
it
a
didn't like my
Raspberry or
key.
Nano, right?
Oh,
Showing you how that works, showing how the cooling works, showing how heating and overrunning.
Fedora.
Right.
Pretty sure it
Then
should
we
be
move
Fedora.
on, right, to the Edge
You
AI,
don't even use pseudo.
quantum thrown into it to like a hybrid quantum classical type thing.
Let me
And
try this other key.
I'm gonna bring the video to campus
Push
in
comes to
April,
shove, I can always just use the other
and
one.
I want to find a way to
Okay, that's not it.
teach a
So
course.
I tried.
It's probably gonna have to be inside of
We have to just use another
Dwayne
one. Just fire up
Joseph's
another one. That might be
linear
the
robotics
move.
course,
So,
but like
what I'm
an
going to
intro
do
to quantum
now
computing,
is
right?
I'm gonna fire up this
CUDA Q, right? But more importantly, what's running underneath.
So
And what excites
what
me
I'm gonna do
is,
is
you know,
go here to the
you
couch.
guys have a physics background,
So you can
think
spin
in
up
the
servers
system,
that run.
understand everything,
Gotcha.
intern with NVIDIA,
So I'm gonna launch
then
this
become an
right here.
employee. That's a stop it.
And we're gonna call
Right.
this
So quantum's gonna
ABC
take over the
test
2030 is going to be bigger in
lab.
2030. So we're gonna make sure we get ahead of it in 2026. Yeah.
And that was talking to other people. Right?
Still gonna do Fedora.
Just to get a little bit of that background.
Yeah, it's gonna be like physics 1 and 2, calc 1, calc 2,
Owned by me.
and then the underlying math. When you think of like a GPU is basically just being like a matrix math machine.
So have you fired
right?
up
Constrained by
instance
thermal
on,
power,
AWS?
basically, right?
Never.
So
Okay.
learn what's underneath, build up, then get to Edge AI.
Cloud.
And in the math machine learning class,
Yeah, that's
I
pretty much
have
the
a
same.
building a
there.
model.
I like the boy thing.
It was before detecting
So you can browse all the
errors
different operating systems.
in the data
Like,
center
you
before they
can
happen,
look
but
for your Mac or
those 3
Mac,
GPUs they have in the math department won't do. The
what we're
data
just
is
going
going
to
to
do
be
is go to the
incomplete.
community.
So we're going to do some digital twinning
and
to
we're just going to search for Fedora. This is what I'm running on
sort of
here. So this
optimize
is
compute.
Fedora right here.
And so that way, that's a real live use
I'm
case.
able to run
Probably
anything I
something what
can run on
QTS is saying, and it was saying, look, we're doing this, bring us in.
For the most part. For the most part, but
So everything
for me,
kinda
I don't have
has
to worry
piece,
about.
right?
Well, Windows.
Have
The reason why I
lab,
stopped using Windows
Data
is
center,
because
you guys get
I would be
increased
working with
exposure.
Windows and it would just
I have
not
you
work.
on Raspberries and
What-
Nanos.
And it was just absolutely
learning about energy, learning about the physics
worse.
underneath. And then once
Absolute
you get
worst.
ready to take your
So-
quantum computing, you'll be ready. As
Uh,
opposed to
bring this up and see.
either
Here we go.
falling
Cool.
for some
Like
BS features or
This is what I
what's quantum
use
computing? What does it
to
do?
fire it up.
Yeah, right.
See
Yeah.
usage.
You have to go
Default
underneath.
username is Fedora.
So
So
the reason why I'm
this is
saying
what I
freshmen and
use before.
sophomores, because it's
Default
gonna probably take 4
is
years
Fedora.
to write the ship, right? You guys gotta get the hands on now, combined with the theory, and then sort of like the industry insiders mentor. That's how you get to your
And
ultimate end game.
for the key pair.
So if you wanna email me,
one of these that I already have.
I'll be
So I
around,
created one. and I
especially
apparently-
when
Wow, look at all those key
Monica
pairs.
from NVIDIA comes to campus.
Let's
And
create
she's gonna do
one
a
just in
workshop,
case.
so
ABC
for
test.
sure. My email is Nolan at Atlanta
Now we're
Atlanta
going to use this for
robotics.org.
use with OpenSSH. And now we're going to create
I'll
a
give
key
it to you
pair.
slow.
So this key pair, so key pairs are a very interesting concept. It's new. These key pairs, even when you are
Atlanta
Bitcoin or
Dash Robotics
committing code, and what it is a public key that you can put
dot
anywhere,
org.
and a private key that you have to keep secret. So that private key
Stay in
is
contact with for
where
real.
is what we're going to keep, and
Nice to
the
meet you.
public
Same
key
here.
is what they're going to put on the instance over there. So, and we see that we're going to allow some secure shell traffic. We're going to allow this other traffic, secure web traffic and regular web traffic. And we're just going to fire it up, launch instance. And that's pretty much it.
Yeah.
So once this gives me I didn't check to see the network. I probably should check to see the networking, but we'll see. Well, once it's up, in theory, I should be able to access it. Let me see what the networking is. I totally forgot to check that. That's the important part in AWS, making sure that you.
Yeah, SSH doing on my machine.
I do not have a public IP. Let me see if I can
No.
see if I can connect the public IP to it.
People guys making you earn it.
Yeah, I know, right? Yeah. So I'm gonna launch just one more, and I'm gonna make sure that This is. Browse with Mouse. I'm just gonna launch one more, and I'm gonna make sure that it has the right networking on it. The other one will probably work, but won't be able to access it, so it doesn't really matter. But this one right here, cloud user, we know that it's Fedora. I don't know why it's not working. It's the fun of messing with Linux. And if I were to just to add VVV, extra verbosity, we would see. That, yeah, this is Linux. So right here, you'll see that it's trying to connect and it's trying all my different keys, but it's saying two authentication errors, and so I don't think it's even getting to the one key that I wanted. Here we go. We'll test. But it just didn't. So I don't know. Wait, let me see. Let me see something. Agent. So I'm putting in my SSH agent, and then I'm going to add that key. EC2. Now let's see what happens if I try a secure shell too, because sometimes you have to use an agent for whatever reason. That works. I had to use a secure shell. So sometimes it you just gotta do it different way.
Gotta be water.
Yeah, gotta be water, right? Yeah, exactly. You got exactly it. So okay, we're on here and a couple users so I can access it from this one. So if you just want to see me add users, so I'm going to become root sudo and then add user. I'm just going to add user AUC2
And root is God power, yeah.
and password maybe AUC2. Not AUC2. So that way, I'm just going to do what 1, 2, 3 A B C. 1, 2, 3 A B C. All right, so now I should be able to connect to it right here.
Password.
Yeah.
Security best practices.
So what's the agent? I've never seen that before.
Yeah, you have it. So the secure shell agent, so you can load in all your private keys, and then it'll take care of authentication for you. Yeah, it's supposed to help, but sometimes I forget that I'm supposed to use it. So 198.144.57. So I should be able to type in permission denied. Let me do. What is it? I gotta tell it to use a password, and I have that right here. So this is where you preferred authentication.
How's it going, my man? So many have been to the garage here.
So I'm telling it to use a password. Preferred authentication. Let's go right authentication. Oh, with an S. Oh, I still didn't like it. Oh well. I don't have the key on here. I do. Let me see if you have secure agent. Oh, cool. You have it in here. So do me a favor, Nolan. Can you oh wait. You download the key that I sent?
Yeah, still.
Control C and then Control V.
Go back
Yeah,
to
just to
mine.
download it
Yeah.
for me.
Yeah, I
Okay,
got
cool.
you.
So what I'm just just to let everybody know. Okay, thank you. All right, just to let everybody know what we did. I fired up the Linux thing. I figured out what I was doing wrong, and the guys' demonstration blessed me with a successful login attempt. And so now I'm going to log in with Nolan's laptop, so I can continue with the rest of the demonstration. Okay. Thank you for your patience. Real troubleshooting. We have to figure it out.
All right, they've both been downloaded.
All right. The AUC2 lab private key is what I need. Where is it? Where'd you download it to?
Uh,
Probably in
my,
the downloads directory.
yes. Yeah, definitely there. Uh,
Let me see if it's in the download directory.
yeah, go ahead. I'm still trying to figure this damn Mac out, man.
Brand new one.
Yeah.
Here, let me try. See if it's in LS.
You're looking directly. I was just gonna take you to the downloads.
It's right there. Cool. So I'm just going to SSH add downloads and then that key AC2. LOL. So okay, so it's telling me that I need to move that to it's insecure, right?
Secure. So you gotta move it to a secure folder. Is that what it is?
Yeah. So I'm gonna move these two to. Okay, cool. Nolan does have that directory. Move it there, and then I'm gonna fix the permissions. That to 600. Now I'm going to add it. Secure shell add AC2 and then AC. So both of them should work. Now, if we secure shell, in theory, this should work. Think it'll work? Want to bet?
Guys love us.
Oh wait, I got the wrong user. So this is only gonna work for Fedora. Boom, we're in.
Yeah.
Yay. Okay, cool. So, all right, we are logged into a nice Fedora system, a nice Linux system. And let me see, we'll make it a little bit bigger.
Thank you for your patience.
Thank you for your patience. So right here, we are logged into a Linux system. And one of the first things that we want to do is we want to show you what exactly is on a Linux system. So one of the first commands we're going to show you is how to list. So on DOS, you'll have something like dir. On Windows is dir, right? That will work here, but it's not really a Linux command. But Linux likes to help you out, and so some certain commands might work. But what we're going to do right here is go to something called the root directory. And this is everything that works on a Linux box. So you have a couple different directories that are common to all Linux systems. All of them are common. And one of them, I'm going to start from the top, is the bin directory. That's where all your binaries are. Those were all your tools, such as ls or shutdown or reload. That's where they live. These are just the tools that you use for the normal day-to-day operation. Now the boot has everything that you need to boot up the system, right? It's pretty self-explanatory. You're probably never going to go in there except if you want to break your system or make it better. There's a couple of files in here that are not really relevant. There's the dev directory. That's where all your devices, like your hard drives, your printers, your mice, your USB devices, everything will live under here. Now, this directory is a virtual directory. The kernel actually manages everything that's in there. So the Linux kernel is what controls all the input output of the system. If you are typing something in, if you are taking something out, the kernel controls that. And it has actually two different special devices and processes. And we'll get that in a second. So everything under dev, I just want to show you real quick, just so that you see, so that it's not just theory. So if we were to descend into the dev directory, and if we were to list it out with ls, you'll see that all these files look kind of like they're colored, they're glowing. Why are they glowing? Because they're special files. They're not real files, they're special files. Right here, there's a device for your CPU, and these are character devices. This is how you type things in. There's floppy drives, right? FD. There's everything in here. There's your login, loop control. There's your hard drives, your super fast NVMe. There's a random. So one cool thing about dev random is if you ever need to just get a random number, you can just access that file and it'll provide it to you. So there's
there's some certain things that the kernel provides. And one thing that's really important are the TTY. TTY? That's legs. Does anyone know what TTY stands for? Anyone want to guess? Talk to me, right? So way back in the day when there were big old mainframes, they didn't have monitors plugged into them. They said a typewriter that was just plugged into it. And you would just type in commands and then the computer would send commands back. Do the typewriter, it would just print on a page like command failed or something. But they would call it teletype. They would teletype. And that legacy has a teletype terminal. Because every way that you access the computer is called a terminal. So TTY is a terminal teletype. This is traditionally how you access a computer. So the name has never changed. It's never changed. Even though we access it via telnet or secure shell or via a monitor or a keyboard, you're all inside a teletype terminal, right? TTY. So if you're ever going to, if you want to see who's logged in on the system, if I were to type in who, so there's a command that is who to see who's logged in, and at the very bottom, let me hit enter a couple times so you see it. It says that I'm logged in as a Fedora user via secure shell, and this is a pseudo terminal PTS0. And this IP address is us here. So this PTS right here, that's the terminal that I'm logged into. It's not an actual terminal, it's a pseudo terminal, right? So that's how you know the difference. That's how you can tell where people are coming from. There's so much information. I may overwhelm you, but if you have any questions, feel free to stop and ask me. So, what did you just say? Because I don't
Anybody have any questions right now?
No. Okay.
Suffer in silence.
So the dev directory, just the dev directory is where all your special stuff is. If you plug something in to your computer, it's going to pop up under dev. The next important one is your home directory. You log in, all your stuff will be on the Fedora user who log in. The next important one is etc. This is all the configuration files. If you have a web server, if you have a database, it's going to be the configuration files is going to be under here. And that's really the important thing. So the etc. directory for like if you want to configure something. If you plug something in, it's going to be on the device. And there's some other stuff right here, but that's really the important stuff. So you have a question? Go ahead.
Yeah, so these are all files on how like determine.
Exactly. So what I'm gonna show you just real quick is a real world use case, continuing off what we were talking about earlier about the web server's down. Oh my God, the web server's down, and everyone's all crazy because we can't make money. So if let's just pretend that this is you setting up that web server for the first time, what would that look like? So it's really simple. All you would have to do is become root. And root is the administrator account on a Linux system. And we're going to clear the screen. So what we want to do is install a web server. So we're going to type in DNF install. Oh, your battery's low. Don't worry about it right now, but HTTPD. And the only reason I know that I'm installing this is because the name of this program, HTTPD, is because I know that's the name of a web server. So traditionally, services are called daemons. And people say daemon, but it's like a daemon. Does anyone know where that came from for a daemon? D-A. Does anyone know where a daemon came from? And then, come on, philosophers, you're supposed to know this stuff. You're supposed to know your Greek history, right?
We're gonna blame Goshen on that one.
So, okay, so you're supposed to know your Greek history. So if you know that they're with the gods and Zeus and the Olympiads and all that, they had helpers, right? And the helpers were called daemons, D-A-E. They were to say the demons, but they're like little cherubs, like whatever, go and help people. Right, and so there's also the plus the math teachers in the class, you got free with them? Oh, we have math majors in here. So LaPlace, he's like the freaking genius of the math world. But he had a theory that there were like little demons and so they can make data.
Yeah, I wanted to ask, so the files from before, how were they actually written?
Hmm?
How are these files written? The files from the previous.
Oh, the kernel files? Yeah, I'll get to that in a second. Let me finish up this one. So the daemons, so just the reason why I even mentioned that, you see that D at the end of HTTP? Most services have a D on it. It's a help. All it wants to do is just help. It helps HTTP. Right. So that's the whole reason why I even brought up the daemons. And it's a nomenclature that says nothing. Nerds are philosophical. Right? So that's what it is. See your question?
We were talking about almost. So all like your commands and command.
So the AFS directory, I don't know what that was. That was just something that's for this, but all your commands are going to be in bin directory. All the commands that you're going to use. All the commands that the super user or the root or admin will be in S bin. You will not have access to that, or you will have limited access to that. So if I just were to go through here, we will see that this will install HTTPD, the web server daemon. It'll install it in a couple different directories. Install configuration file from the server directory. It'll install the HTTP binaries in another directory. Looks like it's application. And then it'll also create a directory for web pages. All of these work together, and they all have security context next to them so that they will work together. But I will show you if this will work. It looks like the mirrors are down for whatever reason. The gods of demonstration, they just will not want us to
I kind
work.
of feel like you brought it on now.
Sometimes it works, sometimes it doesn't. So sometimes we just have a bad mirror. Let's see. Let me see if it's actually here. That don't install it. No, it's not on it. So okay, yeah. So it looks like our we can't install actually an update. So you have a question?
Where does it hold that?
Great question. Fantastic question. So this goes back to Windows 95, actually. So Windows 95, probably before any of y'all was born. So before Windows 95, you had to have drivers for your printer, right? I don't know if anyone remember having driver disks. You had to go borrow your friend's driver disk. Every manufacturer had a particular disk that you have to insert to your computer to make your computer work. The beauty of Windows 95 is that it came with all the drivers for all of the most popular stuff. So you could just plug it in and then tell Windows what computer that you had. I mean, what equipment that you had, and it will automatically just use the right driver. And then it came plug and play, where the hardware actually would give the answer queries to tell you what kind of device it was, and then Windows can figure it out. That's the absolute best. Windows did that very well, and it changed the market. It made computers. Linux did it a bit differently, and they have a database of software. You have the same thing, database of equipment of software, but it's a remote repository. Windows, it came with the repository that's updated. It pulls from Microsoft updated. Linux, it would go and say, this is what I have and what do I need. So it doesn't work as well because you may have some new piece of hardware that someone hasn't written the driver because everything is open source. So it's like, these are just nerds sitting at home like, oh, this doesn't work. I'll make it work for everybody. It might not be available. So for Linux, a lot of hardware, a lot of drivers are maybe a year or two behind because someone has to make it. And the manufacturers may make it available for Linux, they maybe not, because they're not making any money. They want to make money off Linux. So, great question, though, but for whatever reason, this isn't installing, but this is the process. And if my words to my client. I wonder why it's not working. I've pointed to someplace else, but I apologize. This was first time. Different stuff going on, but it's usually very easy, and it'll be your job to figure out why this is not working. But in the interest of time, I'm just going to move on and talk about the directories. Okay. So, and it's probably nothing related here.
I think we will interact with
Not right now because the keys and everything. I have to give out shoot out that key. So actually, if everyone would want to share their email address, I'll go through this for like 7 more minutes in the last half an hour. If you shoot me your email address, I can shoot you the private key that you can try to access it. Right? If you have a Mac, it'll be easier. If you have a Windows, maybe, but if you have a Mac, it'll be easier. But for the next time we meet, what we'll do is we'll iron out those issues so that there'll be probably a couple terminals that you can use our stuff to access it, so you don't have to worry about your own personal configuration.
I totally forgot to announce the guests. Brian and Frank, you just want to say hi real quick?
Everyone, my name is Frank Johnson. I work in Azure hardware, and so the server and rack infrastructure that powers Microsoft Cloud. Good people.
Thanks, Frank.
Hey, what's going on, guys? My name is 27. Currently a software engineer at Dell. So just been big to see you guys and interested in this. I work with some of these teams daily, so glad to see y'all involved, project.
Thank you.
Thank you, sir.
All right, so there's only one real important left to talk about. Everything else is really just stores data or files that you need. But this process directory, proc directory. So this is an interface directly into the kernel, whereas the dev directory, someone asked the question, how those devices, how those files are created. So the kernel will create the device files, and those device files actually will point back to a memory location in proc directory. All these numbers right here, these are programs running on your computer, every last one of them, and you can access what the program is. So if we were to look at, put this down 1 second. If we were to look at process 1, so process 1, I just listed everything out. That's the first program that is run on Linux. Init 1, this is the first. So everything is a child from this process right here.
Brand new computer.
Yep. So if we were to go into that virtual directory, we'll be able to cat the command line. So there's a lot of different things. Everything in here is a command line. So if you want to see what that program is, you see that this is userlib, systemd, switch root, system, deserialized, whatever that means. That's the first program that is run on the system. And you get to see all the information. You get to see what the limits are, what username is running in, where it's mounting directories, what directory that it's working out of, should have CWD, all these things, every computer. So if we were to look at every process, if we were to look at, let me see, I'm just going to list out what process ID I am. So this is me. I just ran this command, and I'm running on PTS1, and that's process 2306. So if I were to see if 2306 is still running, no such ID. Okay, cool. But if we were to look right here, see PTS right, PTS1, this is me. This is the pseudo terminal I'm running into. So if we were to go into, sorry about that, everyone. If we were to go into the process 2223 right here, which represents this process that represents me. And if I were to see what the current working directory is, it will tell me everything, like the environment, everything. This is the environment. It'll tell you what who my user is. If you are a hacker, this is a directory that you would actually go into. If you have access to this directory, you have access to all the information running on a system. The process, the proc directory is only accessible by root, gives you access directly into the kernel. You can actually configure the kernel by modifying some files in here. But this is a virtual directory. And you're probably never going to go into this directory. As practical, the only way you would go into this, the only reason is if you really know what you're doing. But the reason why I wanted to show this to you is to show you the type of power and access you have over your operating system versus Microsoft Windows. Microsoft Windows, you're just an end user. Whatever. You can't even see what is updating when it says performing updates. Please wait. You can't even do that now. But on this, you have fine-grained control. You are able to directly interact with the kernel, which is the core of the operating system. And you will very easily extend it by installing web service if it's working. And other things
2 questions.
to improve the experience. Yeah, so what's your hand first? Right here you
Uh, how do you get to understand and comprehend?
go. And willingness to break things. Great question. I'm an assessment. I'm assessing all this information. I don't need to know all this stuff. But when I break something and I need to know how to fix it, I need to know where to go. Right? What's a good analogy? We'll go back to the car analogy, right? If your car is not working, and it depends on how it's not working, if it's making a click, 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 it's the back. It's customer experience, right? One day your car ran out of gas, you know what it sounds like when the car ran out. When the car is trying to start up and it goes, you know, it's like not catching, might be out of gas, but if you go click, click, battery. So you would look for different things, depending on the problem. You know, so it's just experience for now. It's experience.
I'm currently taking OS and we're on processes and I know like that pre-process.
You give him a microphone, please? The people on the call.
Especially process that's
Well, you kill that process, that stops. It's unability. It's really fun to just bring a system down. But
Do it.
I can show you how to have a massive fork bomb. I mean, the thing is with a lot of these, there's so much power. There's so much power in these systems that out of a misconfiguration or a command, you can take down an entire company, right? There used to be send-mail bombs. I don't know if y'all familiar with that, but it's trivial to be able to send 10 million emails from a system like this to one person. It's trivial. So that's where it comes with a great power comes great responsibility. And sure, I can show you how to just bring this system down. It's really trivial. So
Not my system.
here you go. No, not yours. So here we go. I'm root. I don't even have to be root to do this. This is a fork bomb. But here we go. Boop, boop. Boop, 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 boop. Right there. So this right here will bring down any system. This command right here. What does this mean? I'm declaring a function. That's the colon. And then the function is calling itself and piping itself through another instance of itself. Right? It's just recursion. So I'm just defining it. So if I just hit enter, it's not going to go down. I'll take off that token. If I hit enter, it's going to be like, oh, hey, now we have a new function defined. And just go ahead and take it down. So it's going to take a second for it to fork bomb. Top. Let's see if it's going to run out of memory, if it's going to spawn a whole bunch. So top is how you see what's it doing. But let's see if I forked it right. Let's see, function data open. Yeah, close. Oh, should did that right there. I have spaces. Oh, okay, cool. Now let's go ahead and fork bomb it. Yeah. Let's see if we can. So yeah, I had to put some spaces in there. The system's dead. Oh look, trying to come back. Yeah, it's really easy to take down a system. It's really easy if you don't. And look, resource unavailable. That's because the system is dead. It's trivially easy. It was fun. It was nice to do that, but this is where you have to be careful, right? Because you have great responsibility. In something like this, you have to pay somebody to do it. But someone has to push a button or it's so great responsibility comes with great power comes great responsibility. Any questions?
Couple over there.
Yeah, so like from a consumer standpoint, say you're not like, do you feel like this is like, I don't know, from a consumer standpoint, what might be the benefit of like things over? Because I mean, like it seems like you have more control over your system, but do you feel like that could be like complex to the consumer? Like,
Great question. The advantage cost. This is free. With Microsoft Windows or Mac, you spend $1,000 out the rip, and then you would have to pay for someone to manage it, right? With Linux, you could just teach it yourself, and it just runs forever because it's resilient and reliable. Fortune 500 companies would not use something that is not reliable. Windows is not very reliable. Windows Consumer is not reliable. Windows Server, rock solid. Right? I just don't want to get into it. There's a difference between consumer and enterprise software. So
Right.
yeah, but the Windows Enterprise, you're gonna come out a lot of money.
do you feel like, from like, you think there's people using Linux same way they're using like Windows? Like, say I'm just like on computer watching YouTube, stuff like that. I'm just writing emails, like nothing like.
That's why, yeah, that's my daily driver. I use Linux exclusively.
Okay.
Exclusively. And only time I have Windows is like some game. I do like my Oculus VR, plug it up, and it's all out of date. Any other questions?
There was another one back there.
So I come from the finance background and to the software engineering, coding, intellect. I'm curious, is this sort of how do cyber attacks? I'm curious about.
How do cyber attacks occur? The most popular way a cyber attack occurs is you click on something in your email.
Right.
Or you're like, oh hey, free USB drive. I'll just go ahead and plug this. That's how cyber, seriously, that's how cyber attacks occur. Or someone calls you up, about 5 years ago. Don't give me this. It's the social engineering. Now there's brute force attacks for misconfigured surveys, misconfigured servers. There's in the news there was a couple of dating apps or even vibe-coded applications where the AI stick with security on the database backend. Who would have thought? And then someone who knows someone. So all these apps that you use like Instagram and Snap, it's just a website. It's just a website. That's all it is. And if you were to type into your web browser, turn on the web developer tools, you'll see all the requests it's making. Normally websites have an API. Sometimes you can go right to the API and be like, oh, hey, there's no authentication. I can just type in any name that I want. Including, that's how the Facebook graph thing, when it first came out, there was no security on it. You can just literally download everybody's everything. Okay, well, thank you, everybody.
No, I got you.
Yeah. Right.
Hey, Jeremy, can you get everybody to email me? And then I guess we can add the emails we were talking about. And then also people put private databases in the public internet and people hack it all the time. So we'll do the email thing. The rest of them you just take her around.
Oh, so I just sorry.
Okay, well, I guess not.
Yeah, but what we can do is I can set up a laboratory and we can have more controls over it so that everyone can access it if they just want get them to play around with it. Because this was I can put up an garage data center and it'll be a VM dedicated to everybody that's talking. Great.
Last question. Did you like cancel it's like or there's nothing you could do?
Oh, this isn't bad.
Like you can't even clear it, like control C.
Well, so the problem is you can't get into it. So the problem with all the, we consume every last resource available. So how would you control C? Yeah, because if you were to go into it, it wouldn't let us log in. This right here, it wouldn't let us stop it. That's why it's called fork off. Because there's exponential amounts of resources until there's no resources left. So there's a lot of things like this. So there's cyber attacks. One thing that they would do is they would find some poorly guarded resource like a web server. And let's say that you're supposed to, you can upload a PDF file to the website, right? That's simple, right? A lot of places, upload the PDF file or a picture. Well, when you upload that file, the process that checks to see that it's okay, like, I'm gonna put this PDF file on this username. If you put a specially crafted header in that PDF file, because it's expecting a PDF file, and if it looks like a PDF file, it's gonna think it's a PDF file, but inside there, you have some commands, like some PostScript commands that normally would tell a printer how to print up, but embedded in that PostScript command is a way to tell the computer to delete files. So we upload that PDF and it's processing it, and then it will go and try and delete some files that they are not get them. So the rule number one for preventing cyber attacks is never trust anything that a user does. Anything, like nothing, because they will do unexpected things. That's rule number one. Never trust user input. Sanitize user input. I'm sure some of y'all in class will say sanitize your user input. It's real. It's especially if you're in the financial sector or anywhere else, because people will just try to break your stuff because they think it's funny, and then they want to see how it breaks so that they can learn. It's cyber attacks are not about a team of hackers going in with a digital truck. It's about people needling to death, seeing like what responses, how long it takes for that response, how long it takes for a system to error out, gives more information about what's it doing. There are very smart people out there that are working day and night to bring you down, praying for your downfall. And your job is just to make sure that you do everything right first time. Thank you. Any other questions?
Thank you, guys. Where was my group before? From freshmen, sophomores, physics, blah, blah, blah. Come on. And thank you.
So one thing that we're going to do next time, and we will have a dedicated lab. Again, we're trying to get this up and running, and we'll have instructions on how you can access that lab while we're talking through this, okay? Any other suggestions for the ways that we can improve this? More food?
Tequila with the Mexican.
Yeah. Okay.
So I think what I was pointing out before, what I was trying to tell you is before you say that you just shouldn't stop here, right? Linux with the infrastructure and then you say models and applications. You gotta start here.
Good.
I mean, I feel like I do get this.
Thanks. Just wish I we a little bit more of the demo, but at least I showed how to destroy a machine really.
I can't power something.
At your age, that's when I first started learning. It's just to me like 30 years, but it's a little bit every day. A little bit every day, though. Let's keep at it.
So you're a software engineer?
Yeah, I'm a little bit of everything. I've been a software engineer. I'm an architect. I'm a consultant. So I'm all of that, yeah. IBM, Red Hat, IBM. So yeah, this Red Hat. That's my corporate daddy.
So Red Hat is a subsidiary of IBM?
Yeah, IBM bought them. They bought us, yeah. And what we do, we provide support for Linux systems. So it's really, really good. I had no idea I'll be able to get this job, and I got it just by doing the stuff that I showed you, like installing software. After a while, and hanging out at meetups. So I would go to meetups downtown, just like Linux, and then get a job. That's how it works.
So just things like this just showed up.
Exactly like this, yeah. And then I ask questions like, how am I going to use that? And then just talk afterwards. Sometimes eat a burger with them. And I got a great freaking job. But yeah, I went from having a website in my closet to working for them.
So when did you get hired by them? How long have you been with them?
I've been with them for 10 years. But I was doing stuff way back. So I was building computers in college, and I got into Linux around 2004. Yeah, so it was, and after that it was really easy. It was really easy. I just say, just keep at it. Just keep at it. Just try and play games, get games there. That's all I was doing. I was just trying to get stuff to work, and then after a while, I was like, wow, companies want me to get stuff to work for them. Yeah. It's just breaking it. So yeah, we're gonna have a server, and y'all can break it. It doesn't matter if me break the system. So we just reboot it.
So what did you do like after college? Right after college?
What I do?
Right?
Started companies. So me and my buddy, we started a phone company. And because deregulation was there, we did a lot of ambitious stuff. And then on a website that was cloud storage services a long time ago. I was just free webmail. I was an ISP for a while. I was like, I want you guys to be an ISP. And there's liability with that. People put stuff on your servers, and you don't want that stuff there. And then raise a family, and then I put it all in my closet, and then I was just interviewing, and they just hired me to go and take care of their website. And then I just started programming because I was making just programming stuff. Just streaming cable from my house to work so I can watch the cable TV when I was at home. I mean, when I was at work. Yeah.
Were your startups successful at the same time?
Yes and no. They were, but I didn't know what to do with them. You know what I mean? And then so I went through a divorce, and the business went down because I was the only one doing it. And it's kind of hard to run your business when family's the power company was successful, but then our investors destroyed it because they wanted to. It was making $100,000 a day, and yeah, they wanted all of it.
So they destroyed it and then rebuilt it.
And rebuilt it, and destroyed it. I don't know, but the phone company, that one was a failure because we were hiring our friends. And our friends was just what they didn't care. They didn't care, so we thought it was fun. And we weren't tough enough. But the key is we gotta try. My value to IBM is I tell them, I wouldn't do that. I said I wouldn't do that. Why? I failed a company doing that.
Microsoft and NVIDIA.
There's value in knowing what not to do.
So what would you recommend as like a startup for me now?
How old are you? You're a junior singer? What do your friends want? What do you think? What's your idea?
Foundation first. And also,
I was bootlegging CDs. I was just selling like bootleg CDs. That's what I was doing.
Well, that's literally what I was just telling you.
Yeah. I mean, really, just find a way to make some money. That's if you can find a way to like use the space to make money. It doesn't have to be the biggest idea. It's the simplest idea.
This is the model.
Burning CDs. There's no CDs now, but
I mean legal.
That's your problem. Like, you're worried about whether it's legal or not.
I want to grow it into something, not just like a little side.
You're gonna have to do everything. You're gonna do stuff that which there are no laws. Other stuff is AI stuff. There's no laws governing it. There really isn't. You have to figure out how to make money, whether or not it's legal or not.
One more thing I want to
Steve Jobs, they stole all their technology. For Apple, they sold it for Xerox. You know, and so did Bill Gates sold it from Xerox. Bill was just mad because Steve stole it first. I mean, China steals IP all the time. You don't even have to worry about the law when you get big. Just being real. That's
So
what
they just steal it and then repackage it, market
that's like
and then pay the little fines that come.
we're rich enough. Laws are nothing but a fine. You just have to figure out how. The problem is that people have too much money, and you have to figure out how to have them give it to you. Everyone has money that they want to give away. Why should they give it to you? That's a fundamental question. Everyone in here has too much money. Think about it. How can you get them to give it to you? And it has to be something really simple. Fucking pet rock. I was gonna make NFTs of the rocks in my backyard.
It's a
NFT, get this rock.
I have
NFTs are not legal. Crypto is not legal. People are making money off of it.
as like a gesture.
You just have to figure out how to get. Everyone around you has too much money. It's burning a hole in their pocket. Why should they give it to you? That's what you have to answer.
There's one more thing I want to show you guys. Not that. Am I blocking you?
I'm going this way. Excuse me. You know what I mean? Now?
That's real. It's all about perspective. Mentorship, both in the school and
But all our priorities right.
this is what
I got a house in the
They did, but I'm trying to open it up.
From 30 to about 45.
yeah. You gotta get them from somewhere. And establish the talent, find the talent early. Yeah.
Midtown, they have a.
And then fill it up on the beauty. What?
Where
Oh,
like
making t-shirts?
I'll reach out to
Photoshop.
I was putting memes on t-shirts. It just iron them on.
there's a handful of schools in the world that something like this. The theory, passing on the math on the theory, in the hands-on, $2. There's
Iron on.
MIT, Georgia Tech, Stanford. I run out of things. Forget about HBCUs. No one's doing this. You guys can be the bedrock in the foundation. It's gonna take a good 4 years. Everything else is right. You see, if there's anything else in here I want to show you. Well, that's what I was telling you. All that you would own, as opposed to having to leave it in the lab and take it with you. I've been doing a lot of talking. Any questions about come on? I'll send you my talk that I gave to Afrotech. It's a good 10,000 feet. To where I don't think it'll be too hard. Yeah, but I think that like, why should you care about that? Besides national security. Yeah, faster.
I saw something like
Drug discovery. And personally, don't even know what you can do yet, right? You can't fully run it.
The only I see is like right now the train models have so many different things to that. It takes less time, but it's less resources.
I think that's the long-term use case, like I'm saying, because computers fine. They want to replace it. This is to your point, is a lot cleaner, faster, more powerful. Except we don't know what it can fully do. I'm gonna bring Microsoft and NVIDIA to talk to you guys too. People in the field, people doing research. So don't worry about computing yet. Learn the foundations, and then we'll get to quantum computing. It'll make more sense when you get to it. I'm gonna get physics, calculus,
Yeah, I guess like the best question is like what exactly, how does specific defense science?
Physics.
And so like even within physics, like
Well, you only have like physics 1 and 2.
like mechanics, electricity, and magnetism.
You know what I would really look into? Nuclear fission. Computes the bottleneck, right? The only way we're gonna power this thing is with nuclear fission. Period, right? It's fission and it's fusion. And fusion is a little bit far, but fission is here and now, right? That's what they're doing in the power plants. Amazon is co-labbing, right, with nuclear power plants. I would definitely start there. I even look into a little bit of organic chemistry. That's what they're using it for. That's the lithium use case in a nutshell. And then get into Q to Q a little bit. That's a good enough start. That's a good enough start for vibration. Plus, what we're going to teach you in the lab.
I wonder if there's like classes for like nuclear physics. More. I don't think.
I don't think so, but I'll talk to the wave. I don't think so.
Yeah.
We have quantum physics in for us, but is that similar to quantum physics?
Similar. I would say it would help you with the foundation. It won't be like lost.
Is the only lab in that specific area where or is the just kind of taking
I'd rather you get straight to the point than right. But don't knock it. Right? I'll talk to Dwayne Joseph too. Maybe that was one of the too.
So where did you go?
Let me think about that some more. But for now, we got you. All we got to do is get access to the lane. After that, it's game over. Not running you off. Any questions? I get it. You don't understand it yet, so you don't know what you don't know. But just wait.
Thank you very much.
We'll get you those VMs so you can practice. Sorry.
Like it's just like you start high, bring it low. I know, like I could think of, I can't. All this.
You have to kind of start thinking of the system.
That's the scary part also because we're so like even coming to college, going to high school, it was like it needs like a bit of so like we're just like
Big Tech pushed a lot for 10 years. They just learned the code and everything will be okay. How you doing, my man?
I'm happy. I'm really happy like going to the last 4 years, it's learning code.
That's why I played in the video because you notice they said Coxside used to quit coding, but now it's robotics and data science and everything.
And I'm also the mentorship chair and I know you're in the CS alumni for house. And I want to know if you can do this collaboration. We want to have mentors from the CS alumni. So listen, for our program.
I have to head out. All right, man. Thanks for coming through. Appreciate it. Glad you enjoyed it. All right, man.
So I want to know how we think about that. I have some ideas in terms of getting funded. We actually have this end of the year try where we have that's for the next project. And say, okay, we still take quite a bit of process and do this resume as well.
Yeah, reach out to me. Email me. Yeah, it's Nolan. Yep. At Atlanta Robotics. .org. I'm gonna reach out for real.
definitely missed out on sport. I want to know what else does the Wrestling Center also like work on besides stuff like this?
A lot apparently. There's talks here all during the week that they're showing the Andrew Young movie. So apparently they do a lot in here. So we're gonna do more stuff in here because it's so convenient. I don't know how to. Nor did we tell them goodbye. I'm ending the call, guys.